Okay, so we're supposed to prove that the following two sets have the same cardinality. And they want us to use the Schroeder-Bernstein theorem to do that, which is show that cardinality of A is less than or equal to cardinality of B, and cardinality of A is greater than or equal to the cardinality of B. And the way you prove, oops, and the way you prove those two things is essentially by providing a function that can prove it. And if the function has set property of whether if the function's one to one or if the function's onto, that means it'll have one of these properties. And so that'll then prove that the cardinality of A is equal to the cardinality of B. Okay, so typically it's usually like it's usually easier to come up with a one-to-one function for these type of questions. Just because if you are sure that you're gonna be within the codomain, and if you have a linear function, then you know for a fact that the linear functions it's either gonna be increasing or decreasing, which means that it would be a one-to-one function. So it's super easy to come up with, and it's almost guaranteed that it would be a one-to-one function as long as you make sure that the range of the function is within the codomain. So that's what I'm going to do. I'm going to come up with two one-to-one functions to prove the property. Um, it's also harder, at least I find it harder to come up with an onto function when the range don't look equal. So yeah, so if I come up with a one-to-one function, what should the domain and the codomain be? So I have a one-to-one function. What that guarantees is any element in the codomain, we are guaranteed that it won't be mapped to by more than one element in the domain. So for any codomain element, there's at least one. There's either one or there's zero corresponding element in the codomain. So that means that the domain has to be less than or equal to the codomain. This is because we know that the function's one-to-one. So if I'm using a one-to-one function to prove A is less than or equal to B, their cardinalities, then my domain has to be A and my codomain has to be B. And then similarly, now if I want to prove that the cardinality of A is greater than or equal to cardinality of B, then my domain has to be set B and my codomain has to be A. Okay, so now we actually have to figure out or come up with the function. So we have that the domain is, let me just draw a number line because I think it's easier to visualize it with it. Okay, I'm gonna call that 4. So we have between 1 and 2 and all the real numbers between 3 and 4. And we need to map this onto 10, 11, and this is non-inclusive. Okay. Okay. So I just need to make sure that whatever function I come up with, when I input 1, it has to like the output has to be slightly bigger than 10. And then when I plug in 4, the output has to be slightly bigger than 11. Oh, sorry, slightly smaller than, or I guess smaller than 11, essentially. It's okay if we don't use up all of the elements in the codomain, because this is not an onto function, so I don't have to worry about that. So if I want, I can fit everything between 10 and 10.5 or everything between 10 and 10.25 if I wanted to. Um, yeah, okay. So yeah, usually when you have sets like these, and there's a union and there's like an interval of or a gap that is not included in the domain, I think students tend to come up with piecewise functions. Like one function to for like for when domain or the input is 1 comma 2, and another function if the input is in between 3 comma 4. And that's fine to do. It's not wrong certainly. But I guess it's more work and it's not necessary. Like it's fine if you just have one function that takes any element from 1 comma 4 and maps it between 10 comma 11. Because what that's gonna do is like maybe let me do this in different color. Like this portion is gonna get mapped to by between 1 and 2. And this portion is gonna get mapped to between by elements between 3 and 4. And like there's gonna be this like unclaimed space in between, all of the numbers in between red and blue, and it's fine. It's fine to have that because we don't need the function to be on to. Okay. Yeah, so now yeah, let's actually come up with the function. So if I input in x, and for example, if I input 1, I need 1 to map to something plus 10, slightly above 10. So if I just say x plus 10, then that's gonna shift everything by 10. So then I'm gonna have 4 plus 10, 14, and that's out of the range. So I don't want to do that. So maybe it's gonna be helpful if we scale down the input first. So maybe if I say x divided by 10, yeah, if I say x divided by 10, then any of these numbers would have to be greater than 0, but less than 1, right? Any x value I plug in here, because I can have anything between 1 divided by 10 to 4 divided by 10, and all of those are going to be less than 1. And then if I say plus 10 here, this is essentially going to map to like 10.1 something, all the way to, if I plug in 4 here, 4 divided by 10 would be 0.4. So yeah, 10.4. I think that's what the range of the output is going to be. Um, and this range fits within the codomain. Yeah, so this is a valid function, and this we know that this would also be a one-to-one function because it's a linear function, and it's yeah. So it's gonna be one-to-one. So if I divide it by 10 plus 10, and this would be a valid function. Okay. Now to come up with a function that goes from the code from B to A, that is from 10 to 11, sorry, 10 comma 11 to 1 comma 2 union 3 comma 4. Okay. So here we want to be a little bit careful about the fact that this is a union, about the fact that the numbers between 2 and 3 is going to be missing. Because if I map any of the domain elements to the missing elements in the codomain, then it's not gonna be a well-defined function anymore. Because then I'm gonna have some inputs that map to outside the codomain, and this is not a valid function. Okay. So to make things easier on myself, and because I don't, this doesn't have to be an onto function, what I'm gonna do is I'm just gonna map all of my elements from 10 comma 11 to just 1 comma 2, because that's still a valid function. And I'm just gonna ignore the union 3 comma 4 part, just to make it simpler, because I get to pick what the function is. So I need to map 10 to 1, and then I need to map 11 to 2. So the way I do that is if I simply say, yeah, if I simply say x minus 9, does that work? So if I have 10 minus 9, that's gonna map to 1. And then if I have 11 minus 9, that's gonna map to 2. This is exclusive, but this is inclusive, so either way that it works out. So I can just choose my function to be x minus 9. Yeah. And we know this is gonna be within this is a well-defined function. It'll always map to inside the codomain. And because it's a linear function, we know it's one to one.